Hi everyone. This week we are going to work on kattis problems that involve stacks and queues. First we'll review the stack data structure and we'll look at the classic bracket matching problem solved with a stack. Then we'll review the queue data structure and look at a classic queue problem. So first, a stack is a linear data structure with last in, first out behavior. You can visualize it as a stack of dishes. The last dish on top is the first one removed. Here we have a stack of integers. 10 was added to the stack first, followed by 5, and then 20. When we remove an element by calling the pop function, the last element added, in this case 20, is the first removed. So the stack is a specialized data structure with the following operations. Push to add elements to the top of the stack, pop to remove the top element, peek, which just views the top element, it will not remove it, and is empty, which checks if there are any elements in the stack. Each one of these operations run in time O of 1, which is what makes the stack the ideal data structure to quickly solve certain problems. As far as use cases, stacks are used in undo operations. Think pop the last thing done off the top of the stack and undo it. It's used in syntax parsing, which we're going to look at on the next slide, and in the depth first search algorithm used in graph traversals. So let's take a look at the classic bracket matching stack problem. So we want to determine if a given sequence of brackets is valid, meaning every opening pair of brackets has a closing pair in a valid order. So the last bracket opened must be the first one closed. This is a perfect scenario for a stack. Here's the algorithm. So iterate through a string of brackets. Push the opening brackets onto the stack. Okay, so only the opening brackets are going to be pushed onto the stack. When a closing bracket is encountered, don't push it onto the stack. Here you're going to pop the top element off the stack and check if it matches the closing bracket. Because remember, the last bracket opened must be the first one closed. So the last bracket open should be on top of the stack. So if it is, you're going to continue. If not, then we don't have valid brackets and we can stop checking and exit the loop. So this kattis problem and the solution are posted on kmalone.io, so you can go there and check it out. Okay, so next we're going to look at queues, which is a linear data structure just like an array or a stack, but it's a first in, first out data structure. So you can visualize it like an array. We are going to add to the back of the array and we're going to remove from the front. Our key operations are in queue, which adds to the rear, dequeue, which will remove from the front, peek, which will just view the front item, not actually remove it, and is empty, which checks for an empty queue. So like a stack, each one of these operations are performed in time O of 1. It's used in task scheduling, the breadth first search graph algorithm. Web servers use it to respond to requests, and it's perfect for simulating a circular array. So let's look at a problem that does just that. Okay, so we're going to look at the Josephus problem. In simple terms, people stand in a circle and every kth person is eliminated until only one remains. So children often use this method to pick who's it in a game of tag. Let's look at the example in the slides. Let's say we have people A, B, C, D, and E standing in a circle and we want to eliminate every third person. Here's how we can solve this using a queue. We're going to place all people in the queue. Now we want to eliminate every third person. Remember, queues remove from the front in time O of 1. In a circle, we have no front and back, so we want to simulate the first and last elements touching. We can do this by removing elements from the front and appending them to the back until we reach the third person, and at that point we dequeue that person and remove them. We then continue this method until there's only one person left in the queue. So a version of this kattis problem and the solution is posted on kmalone.io. Okay, so that's it. To get the entire weekly problem set, go to kmalone.io/programming-team/spring-2026. So good luck with the problems and have fun.